Okay, so what we're going to work on today is finding trig functions when you only know one trig function. All right, so let's take a look at the try this. It says solve for x, so I do have a right triangle here. I have one side of the right triangle is 1.3, the hypotenuse is 5.2, and I'm looking for the third side of the right triangle, so we would use the Pythagorean theorem. So that would be a squared plus b squared is equal to c squared. All right, so remember, C is your hypotenuse, and hypotenuse is always opposite the right angle, so 5.2 is your C. So I have 5.2 squared. So it does not matter what you plug in for A and B because addition is commutative. So I have 1.3 squared plus x squared is equal to 5.2 squared. So 1.3 is 1.69 plus x squared equals 5.2 squared is 27.04. So we'll subtract 1.69. We get x squared is equal to 25.35. And square root both sides to the nearest hundredth would be 5.03. Okay, so now let's see what we have to do for when we have one trig function and we want to find the remaining 5 trig functions. All right, so look at the steps here. It says you first are going to draw your angle in the correct quadrant. From there, from the terminal side, you're going to draw a line to the x-axis. This will create a right triangle with your reference angle. You're going to label the right triangle sides with the given trig ratio or the given point. Then you're going to use the Pythagorean theorem, just like we did in the try this, to find the remaining side. Then you can find all your missing trig functions. All right, so let's take a look at the examples. This is pretty easy, so this won't be a big deal. All right, so I have tan A is equal to the square root of 7 over 3, and angle A terminates in quadrant 3. And I'm looking for all of these trig functions, what they're equal to. So the first thing we're going to do is we're going to draw a picture. And it says that angle A terminates in quadrant 3. So here's my angle A. So what I'm going to do is from this terminal side, I'm going to draw a line to my x-axis and create a right triangle. So see, this right triangle makes this reference angle. I call it a reference triangle, reference right triangle. So this is going to be your angle A. So now you want to label this triangle. All right, so you go up to your tangent. Now remember SOHCAHTOA. All right, and tangent is opposite over the adjacent. So this is opposite over the adjacent. So your opposite side is the square root of 7. So go across from A, square root of 7. And your adjacent side, which is next to, is 3. Now, since we are on the coordinate plane, remember when you go to the left of 0 on the x-axis, these values to the left are negative. So you have to label this 3 negative. And your values going down into quadrant 3, your y values are negative. So you have to make this negative. And that should kind of make sense, right? Those are called directive distance, right? It just tells you which way you're going. All right? And the reason why they're not negative up here is because you have a negative divided by a negative comes out to be a positive. All right, so now what you want to do is find this remaining side, the hypotenuse side. So we'll use the Pythagorean theorem. So a squared plus b squared is equal to c squared. Remember, c is the hypotenuse, which is opposite the right angle. So I have negative the square root of 7 squared plus negative 3 squared is equal to x squared. So negative the square root of 7, this right here, squared is 7, plus negative 3 squared is 9 equals x squared. So x squared is equal to 16. Take the square root of both sides, x is equal to 4. Now, since we're talking about the hypotenuse will always be positive. This line will never be a negative here. So let me get rid of this. Okay, get rid of that. So just change something. This side here is 4. All right, so now I want to find my remaining trig functions. So let's start with sine A. So remember, sine is opposite over the hypotenuse. So opposite A would be negative the square root of 7 over the hypotenuse, which is 4. Okay, cosine A. Cosine is the adjacent over the hypotenuse. So adjacent would be negative 3 over the hypotenuse, which is 4. Okay, we already have tangent. So we need cosecant. Cosecant A. Remember, cosecant is the reciprocal of sine. So I'm going to go over to sine here. And I'm going to flip it. So I get 4, negative 4 over the square root of 7. We rationalize the denominator, multiply the numerator and denominator by the square root of 7. So we get negative 4, the square root of 7 over 7. So now we want secant A. Secant is the reciprocal of cosine, so I'm going to go to cosine, and I'm going to flip what cosine is, which is negative 3 over 4, and I get negative 4 over 3. And then the last one I need is cotangent A. So I go to tangent, which is all the way over here, and I flip that, which is 3 over the square root of 7. We'll rationalize the denominator, multiply the top and bottom by the square root of 7. We get 3, the square root of 7, over 7. All right, so flip it over. Let's try the other problem on the other side. Okay, so this says, find the exact value of all 6 trig functions of alpha in standard position if the point 3, negative 2 lies on the terminal side. So we're going to draw a picture. All right, so 3, negative 2, this point here, 3, negative 2, that would be in quadrant 4. So you're going to draw out in quadrant 4, and then you're going to draw up to the x-axis and create that right angle. And then this angle in here will be alpha. All right, that's actually my reference angle. So this is my x value is 3, my y value is negative 2. So this would be my x value is 3, my y value is negative 2. And I'm looking for that side there, which is the hypotenuse. So we'll do 3 squared plus negative 2 squared is equal to x squared. 9 plus 4 equals x squared. So x squared equals 13. Take the square root of both sides, we get the square root of 13. All right, so let's get rid of that. Square root of 13, and it's positive. Hypotenuse is always positive, never negative. All right, so now let's find all 6 trig values. So let's start with sine. Sine of alpha. Sine is opposite over the hypotenuse. So opposite alpha would be negative 2 over the hypotenuse, which is the square root of 13. We would want to rationalize the denominator, so we multiply the numerator and the denominator by the square root of 13. So we have negative 2 the square root of 13 over 13. Now we want cosine alpha. Cosine is the adjacent over the hypotenuse. The adjacent is 3 over the hypotenuse, which is the square root of 13. We rationalize the denominator, multiply the numerator and the denominator by the square root of 13. So it's 3 the square root of 13 over 13. Now tan alpha. Tan is opposite over the adjacent. So opposite would be negative 2 over the adjacent, which is 3. All right, now let's go to secant theta. Secant alpha, sorry. Secant is the reciprocal of cosine, so go to cosine. Now, you don't have to go to here, because if I flip it, you could go to this final answer. If I flip it, I'm going to have to rationalize again. So I want to go to here and flip here. Then I won't have to rationalize. So I have flip that, square root of 13 over 3. I want cosecant alpha, so which is the reciprocal of sine. So I'm going to go to here, flip that, and I get negative the square root of 13 over 2. And then I want cotangent alpha. Cotangent is the reciprocal of tangent, so that's going to be negative 3 over 2. Okay, so that's it, and we'll work some more on this in class. Have a good night.